Hello, welcome to this AWS webinar. My name's Ian Massingham. I'm a technical evangelist with Amazon Web Services based in Europe. I'm going to be hosting today's session. And this is one of our Journey Through the Cloud series webinars. We're focusing on disaster recovery in the AWS Cloud today. And the Journey Through the Cloud is a solutions-orientated look at how you can apply different AWS services to specific use cases or challenges that you might be facing. We have another webinar series called the Masterclass series, where we focus in a series of deep dives on specific AWS services. It's available on our YouTube channel in the link for which you can find in the links panel in the webinar interface. And we have an upcoming webinar very soon, actually focusing on Amazon Redshift in that other series. You can also find a link to the rest of the Journey Through the Cloud series webinars for 2015 in that same links panel in the interface. Other things you can see there, the materials download. You can grab a PDF of the slides from today's session from that materials download panel, that files panel. And that's a good idea because lots of the slides today have embedded URLs in them where you can find further information about many of the topics that we're going to be covering in today's session. You can also see a Q&A panel in the webinar interface, and I and the rest of the team here are going to be doing our best to answer your questions during today's session. So if you are watching live, please feel free to submit your questions about DR on AWS, or for that matter, any AWS related topic. And we will try and take and answer as many of those questions as possible during and at the end of the session today. You can engage with us on social media, and we'll show you a couple of social media accounts at the end of the session, in addition to my own E&M that you can see on the slide right now. We'd love to get your feedback on how we're doing via social media. We'll also put the webinar into what we call Q&A mode at the end of the session today. And when we do that, you'll have an opportunity to give us a rating from 1 to 5, with 5 being the best. And please let us know how we're doing. And if you've got qualitative feedback about the session today, topics that you feel we should have covered in more detail, maybe stuff that you think we overdid, then you can, of course, submit that feedback using that Q&A panel as well. I'd be very grateful to receive that. It helps us improve this webinar program for future audiences. So let's kick off. Today's webinar is the Disaster Recovery webinar in the Journey Through the Cloud series. And like our other program, the Masterclass series, this session today is presented in conjunction with Intel, our AWS technology partners, Intel. Okay, so Journey Through the Cloud. We're going to do three things today, really. We're going to take a look at a common use case and a set of adoption models for the AWS Cloud. Show you and tell you about some of the journeys taken by other AWS customers and hopefully enable you to learn from those. And then lastly, we're going to uncover some best practices that we've identified that you can use to help you bootstrap your projects. We'll also show you some resources at the end of the session today where you can learn more about the topic today, disaster recovery in the AWS Cloud. So why is DR a common use case for Amazon Web Services services? There's a few different reasons for that. One of them is that DR is quite obviously a non-production use case. So it's commonly a secondary environment that you'll maintain for use in the event of certain scenarios arising or recurring. And this means, in a similar vein actually to running development and test workloads in the AWS Cloud, running DR services on AWS gives you an opportunity to explore and learn about AWS with a non-production use case. And of course, during that exploration and learning process, you're going to be putting your applications into production in the form of invocation tests or DR tests that you'll run. So it's an excellent way to make sure that your applications are capable of running in the AWS Cloud. It gives you an opportunity to phase those systems into live DR use with reduced risks, as I've talked about a second ago. There's also a really strong financial case for using the cloud for DR, mainly because you benefit from the lower overall costs of using AWS, particularly when combined with the fact that you're only paying for the resources that you use. Obviously with DR, the majority of the time, you're not going to be in a DR invocation scenario or in a situation where you have to invoke DR. This means that if you're able to take advantage of the elastic nature of the AWS Cloud, your costs really can be dramatically reduced as a result of that. Also, you can use that elasticity to enable you to test DR procedures more frequently and more cost effectively. And with AWS, it's also possible to invoke DR while you're testing DR procedures. And this can be an awkward situation if you have a traditional DR environment and you're testing invocation at the same point as you have a genuine disaster and have to invoke your DR environment. If you've only got one DR environment, that can be a very tricky situation to get yourself out of. And the elastic and practically unlimited nature of the AWS Cloud allows you to have multiple testing and invocation environments concurrently if you need to do that. So there's a strong case for using the cloud for disaster recovery workloads. The agenda that we're going to follow today, we're going to take a look at why you might use AWS for disaster recovery. And we're going to take a look at AWS services that are relevant for DR use cases. We'll take a look at common DR architectures, and in the session today we're going to have time to focus on 2 of the common patterns that we see, but we'll show you some resources at the end where you can learn more and understand a little bit more about how customers commonly use AWS for disaster recovery workloads. So one example of a customer that is using AWS today for DR provision is SunPower. Now SunPower are a global solar energy solutions company. They're backed by Total, which is the 5th largest publicly traded energy company in the world. And their business is all about design, manufacturing, installation, and ongoing maintenance and monitoring of solar power systems. Okay, and this is an organization that some time ago chose to use Amazon Web Services to support its DR use case. There's comprehensive details about why they made that decision and how they've implemented their DR services using the AWS Cloud at the URL that you can see at the bottom of this screen. It's a great example of an enterprise customer that's chosen to use AWS for DR because it helps them improve their compliance posture, minimize costs, and offer the right level of DR services to meet the needs of the users in their organization. And the business and technical drivers for DR in the cloud, as we've already touched upon, are quite clear. You can dramatically reduce costs. In some cases, customers have reported reducing their DR cost structure and therefore their budget planning outlook by around 50% based on a comparison against traditional DR approaches. It allows you to substantially reduce the amount of on-premises infrastructure that you need, and this can provide an opportunity for consolidation of sites, as well as allowing you to remove aging technologies, things like tapes for backup and archiving. They're prone to issues, are difficult to store, and they're not as reliable as modern alternatives. So you can also refresh your technology infrastructure quite dramatically if you make use of cloud computing to deliver DR services. And DR forms part of a wider set of policies and controls that will exist in an organization. You may also have applications, of course, that you've architected for high availability that are really designed to maximize availability. Taking advantage actually of some AWS features like regions and availability zones is one way that you can do this. And these will be apps that you want to keep running 24/7, maybe the front end of your organization where you interact with your customers, or core real-time data processing applications that you want to have available around the clock. You then got a secondary process, which is about making sure that data from these systems and also from other systems that might be engineered to a lower availability level is protected and safe. And then lastly, you want to have the opportunity, if necessary, to recover from that backup data or to reinstantiate those systems after a major disaster. And that's obviously what we're going to be focusing on today, how you do that backup and how you make use of that backup data to ensure that you can meet the availability needs of your organization, your customers, and your stakeholders. And this is not necessarily a binary decision. It's not an all or nothing thing. You need to do an assessment to determine what needs to fail over and what does not. You may have some applications that are more important than others. And you may have some applications that are able to tolerate failures because of the way that they've been designed and the investment that you've made in availability architectures for those applications. So there's an important assessment process to go through when constructing a DR plan to make sure that you have the right provision in place for each one of your applications based upon the impact of those applications not being available. You're going to determine for each one of your applications a recovery time objective, which in essence is how quickly you need the service to be recovered, measured in time, and a recovery point objective, which is very simply how much data loss can be tolerated for this particular application. It might be 0 for certain real-time high criticality, high value applications, or maybe you can tolerate 15 minutes or 15 hours of data loss for applications that are less important, maybe internally focused. And you're going to trade cost against those two things. So the tighter the recovery time objective in terms of how quickly you need to recover a service, and the more aggressive the recovery point objective in the sense that you're minimizing the amount of data that you can afford to lose, the more engineering there will need to be in your DR solution and the more cost there will be associated with your DR solution. And doing that assessment, you'll find that you place applications on a spectrum of complexity. For example, back-end reporting systems and databases. You may decide that you're going to rebuild these when required from an offsite backup because they're only required periodically. They may not be visible to customers. And then moving along that continuum, you may have internal collaboration systems that might be important for customer service purposes, and therefore you want to make sure that they can be recovered quickly. Or you may have customer-facing transactional web applications, revenue-generating apps, where you suffer both revenue loss and reputational damage when these applications aren't available. And these are the apps that you're likely to target for that hot configuration with automatic failover. There's one fundamental characteristic of AWS which is very important when you consider in the context for DR services, and that is that the AWS model is a utility on-demand model at its core. So whereas in a traditional DR environment you may have a secondary site that comprises a replica, maybe a scaled down replica, but still a replica of everything that you have to have in your primary data center location. With AWS, that's not the case. You can have a very minimal DR provision running all of the time, maybe just as small as a facility to receive your storage snapshot data, and still be able to scale up that DR facility if that's required. If you have a DR invocation event or an event which means that you have to invoke DR. This means that secondary site costs can be dramatically reduced in comparison to traditional DR approaches. Another component of AWS which is very important here is the AWS global footprint. The fact that we have regions in 11 different locations around the globe. We have availability zones. Within those regions, each availability zone represents a separate failure domain and contains at least one physical data center facility, but it can be many more than that. And this means that you're able to locate systems in locations that meet regulatory compliance requirements, maybe keeping data in the EU or in the US if that's a requirement for the market within which you operate. And of course, engineering to meet the availability levels that are required from your applications once you've been through a DR invocation event. So you're able to combine the regional footprint and that availability zone construct together to make sure that you can serve your users from the right location globally. You're also able to maintain, if not improve, your security posture when you move services into the AWS cloud. You can find out a lot more about security at AWS if you visit aws.amazon.com/security. But in essence, you'll find that we have a very familiar security approach. All the controls that are required to meet standards like ISO 27001 or the PCI DSS standard for digital payment card information, you'll find that we meet those. We have a very strong, capable security team, which is very large. We have a set of services that provides you with visibility into usage and the resources within your account. And you're able to combine those things together in order to make sure that you meet compliance requirements that might be placed upon you for data and services that you're going to operate from these disaster recovery environments, wherever they happen to be in the world. You can see here that AWS itself aggressively pursues appropriate compliance certifications and accreditations that help us meet the needs of our customers. So if you visit aws.amazon.com/compliance, you can find out a whole lot more about, for example, our ISO 27001 compliant information security management system, or the way in which we comply with the PCI DSS standard. All the standards that are represented on this slide are detailed there, as well as several others that have been acquired in addition to this list. So if you are operating a compliant workload or operating in a regulated market, in most cases there's absolutely no reason why you wouldn't bring those workloads to AWS and operate them for DR or for production for that matter in the AWS cloud. To close up on security, there's one other cool feature of cloud computing, which of course is that we have very significant usage of AWS. Over 1 million customers use the AWS Cloud over the course of the last 30 days. Some of these customers are very demanding. Organizations like GE, NASA, Shell, Bristol-Myers Squibb, Pinterest and others, they're making use of AWS and they're making requests of us for us to raise the bar both on technical features but also on the security standards that we apply. And we do that because our services are entirely standardized and globally consistent. Every single customer of AWS benefits from that. So you have this community network effect, which is further enriched by the partner ecosystem of third-party networking, security, and for that matter, other tools that are available for customers that want to run workloads in the AWS cloud. So it's a very secure and safe place for you to place your data and for you to run your applications and services. Let's move on now and talk about AWS services that are relevant for disaster recovery. I'm going to start by taking a look at storage. So there are several storage services that are relevant here. And if you're a long-time DR practitioner, you'll know that actually disaster recovery often boils down to data availability. Do I have the data that I need in a secondary or tertiary location in order to make sure that it's available if a disaster happens to befall my primary production site or my primary data center location? And there are a variety of different tools that AWS provides to help you ensure that the answer to that question is most definitely yes. Amazon S3, it's a highly durable object store. We're going to return to that in a few minutes and talk about it in a little bit more detail. And we'll talk about AWS Storage Gateway in a few minutes as well. Before we do that, I just want to focus on AWS Import Export. We just renamed the original Import Export service to AWS Import Export Disk. And this is a service that accelerates moving large amounts of data into and out of the AWS cloud using portable storage devices for transport. So what happens here is you will place your data on, in the case of import, you will place your data onto a storage device, a supported storage device. You will dispatch that to us using a physical courier, and we will then transfer your data directly off your storage device using Amazon's high-speed internal network, bypassing the internet and offering very significant performance. So for large data sets, AWS Import-Export Disk is often faster than internet transfer and more cost-effective than upgrading your connectivity for one-off transfer operations. We support data transfer into and out of S3 buckets in the following regions: US East, which is North Virginia, US West, Oregon, US West, Northern California, the EU here in Ireland, and in the Asia Pacific Singapore region. We also support importing data into EBS snapshots in these regions, and we'll return to that in a few minutes to explain it in a little bit more detail. So the process that you would go through is preparing a portable storage device. And if you check the product detail page that you can see at the bottom of this slide, you can find full details on supported devices there. You create a job request and you'll get a job ID with a digital signature that you use to authenticate your device. You'll print out your prepaid shipping label. You'll securely identify and authenticate your device. For example, for S3, you'd place the signature file on the root directory of your device, and you then attach your shipping label and ship your device along with its interface connectors and power supply to AWS. And that's it. We will then load the data into an S3 bucket or create an EBS snapshot if that's the process that you've selected. And your data will be made available in the region from where you can make use of it with other AWS services. So that's AWS Import Export Disk. Now, the reason that we recently renamed that is because we just announced a new service at the recent AWS reInvent event in Las Vegas, which took place from the 6th to the 9th of October this year. And we announced a service there called AWS Import Export Snowball. This is a petabyte scale data transport solution that uses secure physical appliances to transfer large amounts of data in and out of AWS. And this again can address common challenges with large-scale data transfers, so minimizing high network costs, reducing long transfer times, and helping address security concerns. Transferring data with Snowball is simple, fast, secure, and can cost as little as 1/5 of the cost of high-speed internet. Now you're going to receive a physical device here which holds 50 terabytes of data, and you can use multiples of these devices to transport multi-50 terabyte chunks. Currently, this is available for transferring data into the US East 1 region in Virginia and the US West 2 region in Oregon. So there's some restrictions on regional coverage at this stage, but if you are wanting to move data into Amazon Web Services in North America, this can be an excellent tool for that. You can find comprehensive product details at awsamazon.com/import-export. Once you've got your data to us, there's a couple of ways that you can store it. As I said, we'd return to this. So simple storage service. This is our highly durable, highly scalable object storage service. Individual objects can be between 1 byte and 5 terabytes in size, and it offers 11 nines of durability. Let's not say all those nines. So very, very durable. We achieve that durability by writing data that's stored in S3 into at least 3 different physical facilities before we acknowledge back to you that that data has safely been stored. So you can achieve very high levels of durability as a result of that approach. The secondary option that you have is something called EBS, the Elastic Block Store. And these are high-performance block storage devices that can be attached to EC2 instances. And once that's been done, you can create file systems on them or use them as raw devices as you wish. They have comprehensive snapshot and cloning functionalities. In fact, all of the functionality that comes with high-end storage arrays is present in Elastic Block Store, including the capability to support volumes up to 16 terabytes in size. So these are an analog for the enterprise arrays that you might run on your own premises, more cost-effective and elastic in nature. So you're able to create and delete EBS volumes, block storage devices as you wish, using all of the familiar AWS tools. So there's the storage services that are relevant to DR, import, export, disk and Snowball, the simple storage service S3, and Amazon's Elastic Block Store service. How do you connect your data center or network to AWS in order to facilitate data transfer if you want to transfer data across a network connection, or you want to provide access to applications that are running inside AWS during a DR invocation scenario? Several different options for this, which we'll talk about in turn here. Direct Connect, a high bandwidth, low latency connection directly between your data center or network point of presence straight into an AWS region via an AWS Direct Connect point of presence, several in Europe, one here in London, several in Germany, and you can find full details on that at awsamazon.com/Direct Connect, including full details of connectivity partners and where all the AWS Direct Connect points of presence around the world are. The VPC, the Virtual Private Cloud, this is a mechanism for creating your own network topology inside the AWS Cloud and enforcing security controls across that network topology, including things like security groups, network access control lists, routing tables, the presence or not of internet and VPN gateways, and other security features. So very capable tool for building security architectures, network-based security architectures inside the AWS Cloud, ensuring that your DR services meet your information security needs. And lastly, Amazon Route 53. It's a global, highly scalable DNS service which can be used both inside VPCs with a feature called private hosted zones, as well as out on the internet for resolving any publicly accessible service endpoints that you may need to run as part of your application. This is a good place for you to operate DNS records that you might need to update in order to allow for application failover. If you, for example, had your DNS servers on your own premises and they were subject to an outage, there would be no way for you to redirect clients across to the new endpoints where your applications were going to be relocated. So that's also a very important service for disaster recovery invocation. Connecting to AWS, just a couple of options I wanted to talk through in a little bit more detail. So VPN-based connections. To use these, you're going to create a VPC VPN gateway inside your Amazon VPC, and you're going to configure a customer gateway at your premises, which is where we support a wide variety of different VPN devices. You can find full details about those if you check out that, unfortunately, rather long URL at the bottom of this slide. That will enable you to connect your resources in your premises or in your network to resources in an Amazon VPC, a virtual private cloud, via a secure internet-borne tunnel with encryption and authentication on the tunnel, of course. The second option that you have is AWS Direct Connect, as I mentioned earlier, a direct, low-latency, high-bandwidth connection between your premises or network and an Amazon VPC via a Direct Connect point of presence, often delivered in conjunction with actually a wide variety of different AWS network partners who are direct connect partners and provide connectivity at the A or B end, depending on which way you look at it, at the other end of the connection from the AWS POP. So it's a service which is very useful for customers that want to avoid potential traffic disruptions on the internet, maybe provide a secure channel for their traffic, which is more consistent in terms of its performance. So check out Direct Connect if you're interested in establishing one of these direct network connections. And then we have a range of AWS Foundation services, which are going to be key building blocks for running and operating services in DR invocation. Things like Amazon EC2, these are virtual machines that run inside the AWS Cloud, support pretty much any x86 operating system, and you can use them to run your application services or other workloads. Our relational database service, RDS, supporting Oracle, Microsoft SQL, Postgres, MySQL, recently announced support for MySQL MariaDB. That's a way to easily create and operate relational databases in the cloud. Simple console-based or CLI-based setup, very easy to turn on things like data replication, backups, specifying windows for backups, and also will automatically maintain the database with minor version upgrades if necessary. And you create those resources inside VPCs, so you have a very good security framework that you can place around them. And as I mentioned earlier, EBS, a foundational service, actually underpinning both RDS and EC2 services will be EBS storage volumes. It's where you're going to store your data, operating systems, and configuration files. So those are foundational services that are very relevant to this use case. Now going to move on and take a look at some common architectures for disaster recovery in the AWS Cloud. There are four main patterns that we see for this: backup and restore, the creation of pilot-like environments, more on that in a few minutes, warm standby in AWS, and multi-site solutions where AWS resources are combined with those resources on your premises. And during this session today, we're going to only have time to cover a couple of these. So we're going to focus first of all on backup and restore. Then we'll come back and take a look at the pilot-like architectures immediately after that. We'll show you some references at the end where you can find much more detail about those other two architectural options, warm standby and multi-site, but we're not going to have time during today's session to cover those in depth. So backup and restore, what we're talking about here is the simple process of storing backup data in the AWS Cloud so that data is available for you if you need to execute a recovery event. So your backups will be sent to Amazon S3 through a variety of different means, and they'll be stored there so that they're available for you in the event of a disaster. You can also store armies or Amazon machine images for server operating system images. This means that if you do need to invoke DR, you're then able to reconstitute, recreate those servers in the AWS Cloud for disaster recovery purposes, either for testing, which you should do frequently, obviously, or for invocation of DR in the event of a really serious disaster befalling your co-location data center in this example, or your production data center facility. Backup and restore pattern. Some advantages of getting started here, really. Well, firstly, it's very simple to get started. It's a very easy starting point for exploring the AWS Cloud. There's a very low technical barrier for entry. We'll talk about the reason that barrier is so low in just a few minutes. And with this, you can focus on incorporating cloud into your strategy, not into your DR strategy, rather than on complex technical issues that might be related to running systems active or hot. It's also a very cost-effective solution. You've got very high levels of data durability at an extremely low price. The costs of storing data snapshots in S3 are very low, and you have open to you archiving possibilities beyond tape using additional services like Amazon Glacier, which we'll talk about again in a few minutes. The basic pattern is this. So you're going to take backups of configuration state and data from your infrastructure, your server infrastructure. You're going to store those backups in Amazon S3, and you then have an option of moving them for long-term archiving Glacier if you want to have a long-term protection of backup data in addition to a rapid recovery capability. And the reason that the technical bar to entry for this particular approach is so low is that it's extremely well served by AWS technology partners that provide software solutions that are compatible with the AWS API. Of course, we have our own storage gateway, which is a gateway backup appliance in the form of the AWS Storage Gateway. But then you have a variety of third-party backup appliances, as well as a variety of third-party backup management software that makes use of direct access to the Amazon S3 API. and can treat Amazon S3 as a storage unit or a tape or what looks like a tape device in the context of these software products, enabling you to use familiar tools like EMC Networker or Veritas Net Backup or Commvault's backup product, and interface these directly with the AWS S3 API, storing your data remotely and recovering it with familiar tools that your operations personnel are probably very used to using today. Some features of Amazon S3 that make it particularly good for this use case, and one of the, you can find out more details about all those, of course, at awsamazon.com/S3, but one of these recently introduced features is something called the Standard Infrequent Access Storage class. This sits between the Standard and Amazon Glacier storage classes, which used to exist previously. And Standard Infrequent Access offers the same 11 nines of durability, a slightly lower availability level at 99.9, and a slightly longer minimum storage duration. So you have no minimum storage duration with Standard. You have 30 days minimum storage with Infrequent Access, and you have a minimum object size of 128 kilobytes. And then you have reduced charging for data retention, but you do pay a retrieval fee. Now, in the case of backups, obviously the majority of backup data is not accessed. So for most backup use cases, Standard Infrequent Access will offer a more cost-effective mechanism for data storage than Standard S3, whilst maintaining the immediate milliseconds first byte latency characteristic of S3 to enable you to restore data rapidly if you need to do so. Now, you can find out more details about this on the AWS blog. My colleague Jeff Barr, also from the evangelism team, wrote a post there on the 16th of September introducing this service, which includes a full console-based walkthrough of how you can get started with it on S3 buckets. So if you're interested in that, just visit the Amazon official blog and you can find out more information about Amazon S3 Standard Infrequent Access Storage class there. Did mention Glacier there, and this is still relevant for backup and archive use cases, so it's worth covering again. awsamazon.com/Glacier if you want to learn more about it. This offers you the same 11 nines durability level of S3, but it's designed for write once, read never workloads. Cost efficiency comes in the form of a pricing band that's roughly a third of the price point of Amazon S3, but you have to trade off access latency for that, and it can take 3 to 5 hours to access data from Glacier once you've made a restoration request. So it's not suitable for applications where you have an aggressive RPO, an aggressive recovery point, an aggressive RTO, regressive recovery time objective, because you're going to have a delay in getting your data back from Glacier. But if you want to cost optimize, then this can be a useful tool. It also offers some helpful long-term lifecycle management features. So for example, you can expire objects automatically, specifying a policy on your S3 bucket to tier objects down to Glacier and then delete them after a pre-specified period. As you can see here, so you'd have an object transition to Glacier, which is invoked. You can then restore objects. Objects will be restored and held in S3 RRS for the specified period that you make when you make the retrieval request, and once that period's run, the objects will be deleted from RRS and will continue to be held in Glacier until they either expire due to a lifecycle policy or you issue a deletion request via the API. So you do have this mechanism for managing data long term using Glacier, which can significantly reduce the costs of managing large data volumes by virtue of that automated expiration process that's available to you. The other storage service that I mentioned at the top of the session, which is relevant here, is the AWS Storage Gateway. This is somewhat unusual for an Amazon Web Services product because it's a piece of software that you install on your own premises. So you install it in virtual infrastructure, VMware, Hyper-V, and I believe that there are other hypervisors that are supported as well. You can find out more at awsamazon.com/storage gateway about the support list. And once you've done that, you can create local volumes under the storage gateway. And these volumes will be usable with on-premises servers via the iSCSI protocol, via an iSCSI interface essentially. And you can read and write data from those volumes as though they were local block devices. Once you've got data in those volumes, you can snapshot, compress and store those volumes in Amazon S3. In fact, that'll happen automatically for you. So there's no action to take once you've configured. Your volumes will be synchronized back into Amazon S3 and they will be protected for you. And in the event that your primary data center suffers a catastrophic incident, maybe you have a fire or flood and your local storage devices that were connected to your storage gateway are destroyed, well, you can pull those snapshots back from S3 to restore local volumes, or you can pull those snapshots from S3 to create cloud instances backed by those volumes. So this is a mechanism for easing integration with between on-premises storage infrastructure and resources that are located in the AWS Cloud. There's a couple of different options here. Gateway stored volumes. These are where data is principally stored locally on the storage gateway or on storage infrastructure attached to the storage gateway. They're asynchronously replicated, backed up to the AWS Cloud in the form of EBS snapshots. They provide an iSCSI local interface. You can have up to 16 terabyte volumes and you can have up to 12 volumes. And then you have gateway cached volumes. Here the default is that data is stored in S3, but recently read data will be cached on the storage gateway. They offer low latency. There's again an iSCSI local interface. Here you can have up to 32 terabyte volumes and you can have up to 32 of them. So you need to evaluate those two options and consider which one best fits your use case. There's a third mode, which is to run your AWS storage gateway in Gateway Virtual Tape Library or VTL mode. And this allows you to have access to a limitless collection of virtual tapes, almost limitless collection of virtual tapes. Each virtual tape can be stored in a virtual tape library backed by Amazon S3 or in a virtual tape shelf backed by Amazon Glacier. The virtual tape library exposes, again, the industry standard iSCSI interface, allows your backup application with online access to the virtual tapes. If you no longer require immediate or frequent access to the data, you can use your backup application to move it from the VTL, the virtual tape library, into the virtual tape shelf in order to further reduce your storage costs. And here you'll start to take advantage, obviously, of Glacier pricing instead of S3 pricing. Each virtual tape can be stored in a virtual tape library backed by S3 or by a tape shelf backed by Glacier. Each tape library holds 1,500 virtual tapes with a maximum aggregate capacity of 150 terabytes. And there's a list of supported software for VTL, again available at the rather long URL at the bottom of this slide, which will illustrate to you supported systems, including products from Veritas, Microsoft, Veeam and Dell that have support for Gateway VTL mode on the AWS storage gateway today. Of course, you can use third-party storage appliances as well, and you can use them as a mechanism for making data available in secondary data centers if you wish to do so. Here you can see an example architecture of a customer that has storage appliances in 2 corporate data centers, and they're backing up data to Amazon S3 using those devices, and they're able to access that data back in those 2 data centers as required. There's also a reference architecture for using RDS with Oracle RMAN for recovery. So this is the Oracle Recovery Manager, of course. We're not going to cover that in depth here, but if you are running Oracle and you're interested in strategies for data recovery from Oracle inside the AWS Cloud, then you should take a look at the white paper that's referenced at the bottom of this slide, which talks about strategies for migrating Oracle databases to AWS. And there's a section in that white paper about using RMAN for data transportation, including in recovery scenarios. If you do want to learn a little bit more about DR for Oracle using AWS in combination with RMAN, then check out that white paper for further details on that. Next thing I'm going to do is take a look at the pilot light pattern. And this is an architecture where you're going to build resources around a replicated data set. And you're going to keep your pilot light on by replicating those core data sets, for example, databases or core file systems that need to be replicated. And then you're going to build AWS resources around that data set, and you're going to leave them in a stopped state. This means that you're not going to be paying EC2 instance charges for those resources. You're simply going to be paying for the storage of the root volumes from which those resources will boot in the event that you need to invoke your DR process. This allows you to scale your AWS resources in response to DR events, whilst at the same time being cost optimized and minimizing your expenditure. So you're going to start up a pool of resources when events dictate, might be testing or real invocation events. And then you're going to match required production capacity using auto-scaling policies. And this essentially allows you to cut your system over to AWS, subject of course to you being able to move things like DNS endpoints for services. So that's an important prerequisite for this sort of architecture. And from an architectural standpoint, it looks like this. So you're going to have your co-location or on-premises data center. You're going to be performing regular or even continuous database synchronization, which will be backed by an RDS instance or a database instance that you might manage inside the AWS Cloud. You're going to have that attached to EBS volumes that in turn will be protected using EBS volume snapshots. And then you're going to have pre-prepared Amazon machine images or armies for each one of the instances that you need to have present in the data center in order to run your application. And then in the event of a disaster scenario occurring, you're going to turn those stopped instances into running instances, and you're going to move over endpoints to make those services available. And that's it. You then got a situation where you're able to invoke DR using that pilot-like light architecture with your data sets in place in AWS when you need them. So that concludes our content for today. Take a look at a few resources now that you can use to learn a little bit more about DR in the AWS Cloud. The first is the DR Solution Center on the AWS website at awsamazon.com/disaster recovery. And you'll find here links to many of the other resources that I'm about to show you in a second, as well as customer case studies for a wide variety of customers that are using AWS for DR workloads today. Next resource is the AWS Disaster Recovery White Paper. And this is the location that you want to check out if you want to learn more about the other two DR solution patterns, architecture patterns that we didn't cover during today's session. So the white paper contains actually much more detail about the pilot light and backups in the cloud patterns, as well as comprehensive descriptions of the warm standby and multi-site solution patterns that we see customers making use of, in addition to the two patterns that we've already covered in this session. And if you only download one asset, one piece of follow-up material from this session today, I would recommend it is the white paper. And you spend a little bit of time learning about common approaches that customers take to running DR services in the AWS Cloud. There are several service pages that are relevant given what we've talked about today. I've pulled out some highlights here: VPC, Direct Connect, S3, Glacier, and of course the storage gateway. You can find all of these either from within the console or from the AWS homepage, but you can also jump directly to the relevant service pages by using the URLs that I've shown on this slide. And as we just came off reInvent a couple of weeks ago, I found this excellent video about deploying disaster recovery sites on AWS from the reInvent YouTube site, or rather the reInvent YouTube playlists on the Amazon Web Services YouTube page. If you visit the URL at the bottom of the slide here, you'll be taken directly to this video, but you'll also be taken to a playlist which will show you all of the storage related sessions from AWS reInvent 2015, and you'll see that there are several sessions in the playlist there that are relevant to disaster recovery use cases, including one on disaster recovery migration and several others on backup and data storage in the cloud. So again, this is a very, very valuable resource. Videos are typically 45 minutes to an hour in length, and an excellent way to digest expert level content on how you can use AWS to fulfill this specific use case. There's also the AWS Architecture Center at awsamazon.com/architecture, which has one particular pattern that relates to the use of AWS for DR for local applications. It's the Oracle RMAN architecture that we've already featured in today's session, covered in further detail in the AWS Architecture Center, so you can check that out. And if you're interested in developing your AWS skills more generally, you may be interested in AWS training, certification, and self-paced labs. You can find more information about all of those topics if you follow the URLs that you can see on this slide. Particularly in training, we have architecture and architecture professional level training and associated certification now, which is an excellent place to start if you're interested in building solutions in the AWS Cloud for your organization. So check out those training offerings. We're going to stop in a second and take a few questions, hopefully answer a few questions live in the session. But before we do that, I just want to call out a few social media accounts that you may be interested in. Please do submit your questions while we do that using the Q&A panel that you can see in the webinar interface. Also ask my colleague to switch us into Q&A mode now, so you can give us that rating between 1 and 5 and let us know how we've done. Of course, you can always submit feedback via the Q&A panel as well if you want to do that. And do follow us on social media. You can find us here in the UK and Ireland at AWS_UKI. Stay up to date with local AWS events, news, other education opportunities that might open up here. And our global Twitter account is at AWS Cloud, where you can stay up to date with global AWS news and new services announcements, as well as lots of how-to guides and other useful content for users of the Amazon Web Services Cloud. So that's everything we've got for you today in terms of content. You can find me on Twitter at IanM, of course. I'd like to thank you, as usual, for giving up your time to learn a little bit more about AWS. I really do appreciate you spending your time to learn a little more about our services. If you do have questions, please continue to submit those using that Q&A panel that you can see in the webinar interface. And let's turn now and take a few questions. Thanks for joining us today.